I want to start off with first just introducing myself a little bit. I've been in biotech for a long time. I've been doing a lot of stuff in cancer research, heart disease research, inflammation research. I played a big role in discovering human growth hormone, something called tissue plasminogen activator, erythropoietin, and Betaseron, the first drug ever for multiple sclerosis. So I've had a pretty big career in the field before I actually got into the stuff that I'm going to be talking today. But my interest has always been aging. I've always thought that's something that's wrong with all of us. I love living, okay? I want to live as long as I can, as long as I'm healthy, okay? So the number one goal of anything that we are working on is to make it so that we can extend our health span, make us young and healthier, younger, and stuff like that for a long time before we actually start doing things to make us physically younger. And but that's the big goal. It's always been of my interest. But throughout my life, I kept thinking that everything I've ever heard about aging didn't make sense. People always have wanted to compare us to old trucks sitting in a field that were exposed to the weather, the wind, the rain, the sun, and we deteriorate because of that. But humans are different. Like when we get a sunburn, we kill cells, but we have other cells that divide and replace those cells, brand new cells. Why do we get older? And so that was something that didn't make sense to me. And so I decided that all these theories that existed, I just couldn't be bothered with. I had to wait until something came along that would explain a clock, kind of a clock that ticks inside of us. And it was many years before that came along, so that's why I did cancer research, heart disease research, and inflammation research during my first, let's say, 12 or 13 years of my 33 years in biotech. I have 45 US issued patents on the stuff that I'm going to be talking today, which is quite a lot for somebody in the biological fields. Chemists typically have that many, but that's a lot for this kind of field. I was awarded second place for United States Inventor of the Year for the stuff that I'm going to be discussing. My colleagues won the Nobel Prize in Medicine for the stuff I'm going to be talking about. So this is really picked up as a major science right now. And that's good because quacks and charlatans have been discrediting this field of anti-aging for thousands of years. And so it's really good now that we have some real science that is backing up. And as I'll show you earlier, scientists now today have successfully turned old mice into young mice. This is the first time in the history of the planet this has really been done, and I'll come back to that bit later. I have been featured in Popular Science for the research that I'm doing. This is about 3 years ago. I am presently in a documentary called The Immortalist that talks about my research. You can Google it, you can find it there, but you can actually download it. It actually came close to winning an Oscar this last December. It made it in the top 100, but not the top 10 for consideration for an Oscar. And it was also like the #1 independent film being sold on iTunes when it came out on iTunes for the first 2 weeks. So it's pretty good. It gives a good overview of the science. Also has both Molly and me in it, in our personal lives a little bit. But I would say that this is a good place to learn more about the stuff I'm talking about. Another documentary just came out 4 days ago, actually. This is called The High. Molly and I are both ultra-marathon runners. And this is an incredible race in the Himalayas of northern India. It's it's 222 kilometers long. You run this nonstop. And if you didn't think that's hard, it's at 5,500 meters altitude. Okay, so pretty hard to breathe and stuff like that. But Molly became the first American woman to ever finish it. And I think it's an exciting thing. And it also talks about my science, okay, that you'll hear about today. They seem to go hand in hand. I seem to be doing ultra somethings. Okay, so then also, if you want to learn more about what we're talking about, I have written a book called Curing Aging. Put your thinking caps on because I'm going to be asking some questions during my talk, and whoever gets the question right first is going to get a copy of the book. But I recommend getting this book. It's available at Amazon.com. All right, so the subject is curing aging. That's what I'm all about. I'm focused on trying to find ways to cure aging. I call it curing because I think aging is a disease. Just because we all have it Doesn't mean it's not a disease. It's just something we're all the less fortunate because we all suffer from it. A lot of people give me criticism because of the fact that I call it a disease, but I say to them, when we come up with a cure for it, you'll call it a disease too. And that's so curing aging is what I'm all about. I learned this term when I was only 10 years old, and when my father told me, grow up, become a doctor, and cure aging. So that's been my focus. There's a lot that's already been done. I'm not the first one that has come along to try to find a cure for aging. A lot of things have been done. Like in the early 1900s, we only lived to be about 47 years old. Now we're living close to 80 years old. And it's because of a lot of things that have been done. Eyeglasses, which is one of my favorite examples. I mean, we couldn't hunt. We couldn't escape predators and stuff like that when our vision went bad. But now, we've developed ways to be able to do that. Eyeglasses, but even better sewage systems, vaccines, refrigeration, all these things have extended our lifespans. Chemotherapy, you got cancer, now you have a better chance of surviving the cancer with chemotherapy. Heart attacks, you have coronary bypass surgeries that are going to make a lot of us survive. And unfortunately, what's happening as a result of this is we're getting a lot of older people. Okay, these things extend our lifespans, but they don't actually make us younger and healthier. So we now have a big population, especially with the baby boomers, getting older, and now in some countries it's something like 40% of the population is expected to be over 65 by 2030. And how are we going to take care of these people? So this is, even though these have been good things to save us in a lot of the diseases we've had, or a lot of things that kill people off, we still have this big problem coming up now that we're going to have a lot of old people. It's called the silver tsunami that we're expecting. And so I think the solution to the silver tsunami, it's also a financial burden, because how are the governments going to pay for taking care of all these old people? Well, the way to do it is to keep them from getting old. Keep them young and active and able to take care of themselves when they're over 100 years old. And I think that's what we're doing, and I think science now is got a solution to that problem, and you'll hear a lot about it in a few minutes. But as a result of everything we've done, it's nice. We've got a great lifestyle now. This is the best example of 45 is the new 65. We are seeing the right doctors, getting the right exercise, taking the right supplements. We're living a lot better than we used to, let's say, in 1900. And so I hope everybody is trying to be as good as these 65-year-olds. But I'm actually a little harder to please, because this is not what I'm about. When I turn 65, I want to be like this. And that's what I want for all of us. That is what I'm striving for, and I think we can do it. Now, how do we do it? Well, there's a lot of theories on why we age, and I'm not going to go through all of them here, and I'm not going to go through any of them. I just want you to see that there are a lot. And my attitude is instead of questioning them, let's just believe they're all true and start practicing every one of them to stay healthy as long as we can. Well, what I like to do is I like to think of each of these theories as a stick of dynamite that's burning inside of us. So we have multiple sticks of dynamite burning all at the same time. So we've got all these theories of aging causing us to age at the same time. But what really matters is which stick of dynamite has the shortest fuse. And I think that shortest fuse in humans is telomeres, which is the main thing I'm going to be talking about today. And I'm going to guess that most of you already know what telomeres are, but so let me just run through, maybe there's one or two that don't know. To explain what a telomere is, they're very small things inside of us. So we've got to zoom in on a human being. And we find that a human is made up of 100 trillion cells. Now, most of the theories on why we age say that we age because these cells age. So most of the research I do at my company is figuring out how to stop the aging process or reverse the aging process in the cells themselves. So we zoom in any further, we see that every cell contains a nucleus, and inside the nuclei are found the chromosomes. We'll zoom in on one of the chromosomes. Chromosomes are where our genes are. They give us our hair color, our eye color, et cetera, et cetera. the genes are organized on a molecule called DNA, which is like a long string of beads. I want you to think of it like a long shoelace. The beads are called bases, and a typical DNA is about 100 million bases in length. Along the sequence of these bases is where the coding sequence for our genes that give us our hair color, eye color, stuff like that. This shoelace-looking object is all coiled up like a slinky from one end all the way to the other. Because it's so big, it has to be condensed into this thing. Now think of that shoelace again. What do you have at the end of your shoelaces? You have caps. The purpose of those caps is to protect the telomeres, or the shoelaces. Well, our telomeres also have these caps. See, our chromosomes also have these caps. These are called telomeres, shown here in yellow. That's at the very tips of our chromosomes. Now, if we unravel that telomere, the slinky, something's back, we find that the, let me go back this. We find that the telomere is about 15,000 bases in length. Remember I said the DNA in your chromosome is 100 million bases in length. The telomere is only 15,000 bases in length, at least when we're first conceived. And this is a critical point because this is where everything starts happening. This is where all the problems begin. The reason why we age is because every time our cells divide, our telomeres get a little bit shorter. So 15,000 bases when we're first conceived, we start growing up. By the time we become a newborn baby, we've gone through so many cell divisions that our telomeres have shortened to 10,000 bases already. I'll say this over and over again. This is fact. This is not theory anymore. Every scientist in the world has seen this. You can look at human cells in petri dishes from different tissues of the body or just cells grown in the petri dish. You can see that the length of your telomere is very correlated with your age. People can measure your telomeres, take some blood, measure your telomeres, and tell you how old you are. This is now real science. Now, the problem doesn't end here. Telomere is already down to 10,000 bases, but you still have a lot more cell division to go because you've got to grow up to become an adult. So as you do this, there's more and more cell division. You get bigger and bigger and bigger, and your telomeres get shorter and shorter and shorter. And when they get down to 5,000 bases, you die of old age. This is where, when telomeres get down to 5,000 bases, our cells lose the ability to function. We know this from cells in a petri dish. Again, we know from different tissues in the people at different ages. We can see that when telomeres get down to 5,000 bases, our cells quit being able to work. And I'll explain a little bit later more details about why, but it's pretty much like what happens when the caps on your shoelaces get really short. Your shoelaces start falling apart. And you can see these rearrangements of chromosomes in the microscope when you look at old cells. And so that's what we want to stop. But let me go over this one more time. We're conceived at 15,000 bases. We're born at 10,000 bases. And we die of old age at 5,000 bases. And there's absolutely nothing we can do about this yet. This is everything you've been doing. Nothing, you can't stop this. No matter how well you eat, no matter how much you exercise, no matter how much you do everything your doctors tell you to do, you can't stop this. Okay, it's going on and on and on. You can do things to accelerate it, which I'll come back to in a few minutes, but you can't stop this. And it's the only clock of aging that's ever been discovered in humans.